Yeah, pure substance, right? PT diagram means pressure volume diagram for water, right? Initially, we have water in a piston cylinder, right? Inside this, we have water here, right? Right. This is a massless, right? So here this is water. For example, this is at a 20 degree centigrade, right? And here pressure is atmospheric pressure, P equals to P atmosphere, right? So when we put heat on it, right? So when we heated it, right? So its temperature will increase, right? Temperature will increase, it means its density will go down, right? So then its temperature increase and increase, we reach at a 100 degree centigrade, right? So then temperature is 100 degree centigrade and same pressure, right? So this stage is called saturated. So it becomes saturated liquid, right? And we further heat it. So what will happen? Some liquid will convert into vapor. So here it's a vapor. Further heat this system. So some water will convert into vapor, right? And here some water, right? Still its temperature remain constant. It's a 100 degree centigrade, right? Because here phase change is there, right? During the phase change, we know temperature remain constant when pressure is also same, right? So if we put further heat here, right, further heat it, so we reach another state where the water completely convert into steam, right? Here it's a complete vapor. Here it is water, so we can say it's a steam, right? So this vapor, its temperature is still at a 100 degree centigrade, right? Because this is the saturated steam, right? And we further heat it, right? Further heat it, so its temperature increases, and this is called superheated steam. Superheated steam, because its temperature is higher than the saturated temperature, right? So this is these 5 stage, right? This is the state 1, this is state 2, this is state 3, this is state 4, and this is state 5. So all these 5 states I want to draw in a temperature and specific volume diagram. Volume, it's a inversely proportional to density, right? So V equals to 1 upon rho, right? We know the density of the unit of density, it's kg per meter cube. It's a meter cube per kg. It means 1 kg mass of substance, how much volume it's occupy, right? So when we will draw it on a TV diagram, right? So initially all these state, right? This is the state 1, this is state 2, this is state 3, this is state 4, this is state 5. All these 5 states I am drawing here in PV TV diagram, right? So initially it is here state 1 20 degree centigrade, this is temperature, so this is a 20 degree centigrade, right? When we heat, so it becomes saturated. We read here, this is the point, this is point 1 state 1, this is state 2, right? We reach here, this is the saturated liquid, right? And its corresponding temperature is 100 degree centigrade. This temperature is 100 degree centigrade, right? And this is the saturated liquid, right? Then we further heat it, so what will happen? So some water will convert into the steam. So we reach at this state, right? This is state 3rd, right? When we further heat, so all the liquid, right, it's a water, so it will convert into completely in steam, right? So here temperature is also 100 degree centigrade, right? Because this is the phase change, right? So this is state 4, right? Then we further heat it, so we reach at this point where its temperature is increasing. Now it will higher than the this saturated temperature, right? Because all the liquid is already converted into the vapor, or here it's a water, so it's a steam converted into steam, right? We reach here, this is state 5, right? So this is the superheated state, right? Superheated steam, right? And further we increase the pressure. For example, now what we are doing, we are just adding here some weight, adding some weight here, right? Adding some, this is weight, adding weight. So then further heat and then repeat this process, right? So when we repeat this process again, so what will happen? We will get also same thing but in a different temperature, right? Now atmospheric pressure is different, means higher, right? So higher, so here similar thing we will do for this process, right? So we reach here and again we will this one, and again for the different state, so we reach for different pressure, so we will reach this curve, right? So when we draw these lines, this is the saturated liquid, right, here, and we reach here, right? So we will get this type of dome, right? So here this region is called subcooled region, right? This area, this region is called subcooled. Why it is called subcooled? Subcooled, how it is defined? Subcooled means the liquid temperature less than the its saturated temperature, right? Liquid temperature less than its saturated temperature, right? For example, we have water at a 20 degree centigrade, water at 20 degree centigrade. This is called subcooled liquid, right? At a constant, this atmosphere pressure, है ना, P equals to P atmosphere. This is very important at a particular pressure, right? So this is the subcooled liquid, right? So this water is subcooled water, right? So similarly here inside this dome, here liquid plus vapor will exist, right? Some part is liquid, means at this point, right, liquid start for converting into vapor, right? So in this region some liquid is also there, but for example for here, right, more is liquid, less is vapor, and further heat when we reach here at this point only vapor is there, right? Is called, this is the saturated liquid curve. This curve is called saturated liquid curve, or we can say in line saturated up to here, right? And further, if we further right, so this line is called saturated vapor curve or vapor line. This is, right? And this area is a, this here I am drawing this area, complete this area, it's a superheated vapor, right? In the right hand side from this curve, right, from the, this is right hand side from this curve, saturated vapor line, right? This area is a superheated vapor region, right? And at the top here, this is called critical pressure, right? So in this point we cannot able to identify the difference between liquid and vapor, right? P critical, here P critical pressure, we cannot identify the it's a vapor or it's a liquid or it's a vapor, right? Liquid and vapor we cannot identify, right? So at a P critical, here the P critical point, right, at a critical point C, here pressure is 22.06 megapascal and temperature is 374 degree centigrade.